I want you to take a moment to think about how your eye is able to differentiate the colors in this image. To understand this, we have to go all the way back to the first instance of biological light capturing devices. By the way, I'm not a biologist, so don't get mad at me. The single cell light capturing device was only able to capture light from one direction. It was very inefficient. So over evolution, it was able to adapt and have more cells that were able to take in light from different directions. And then over time, we were able to evolve that into actually an eyeball shape. And then it had multiple areas for light to come in. So it gave a very blurry image. And through evolution, it gave us eventually a pinhole, which allowed only one source of light to come in. And that's how we were able to finally see an image. This pinhole that I'm talking about is your iris, and the human eye actually has this very fascinating feature where when it's dark out, your iris will actually expand. It will allow more light to come in, and it gives you a little bit more of a blurry image, but you can still see at night. But when it's brighter out, the iris will actually shrink when it's bright out, and it will actually let in less light so that you can actually see a very sharp image. Taking a closer look at the eye, we actually see mainly two types of photosensors that it has. It has rods and it has cones. So in the human eye, you only have about 120 million rods that are in the eye that are around the peripheral side that help with low light conditions. And you only have about 6 million cones that are responsible for the color in your eyes and are responsible for more brighter and more sharper imaging. And as a fun fact, this is actually where a lot of colorblind people have a defect in their cones in their eyes, and they're unable to see a certain wavelength of the color light spectrum. Again, I'm not a microbiologist, but these rods and cones are connected to ganglion cells, which also, if you notice in this image that they have multiple rods that are connected to one ganglion cell, whereas the cones are more connected on the 1-to-1 ratio. The left side of the image is actually like the inner wall of the eye, and then towards the right is the back of the eye where all the neurons will actually go. And the ganglion cells are the ones that detect the light, and then it translates that information to the rods and the cones. So these ganglion cells are actually activated by light, and there's two different ways that they can go about that. There's the on center and the off center, and they work in opposite ways. So in this image here, it shows the on center ganglion cell being activated because the center of the receptive field is being stimulated by the light, and the surrounding area is not actually. And this is what sends a signal through the rods and the cones and into your brain, telling you that there's an edge detected in that spot. So going back to the first image that I showed, this is how your eye is able to see the different colors. The on ganglion cells are firing the most where the edges are. Computer vision models in the early days, they actually used the same technique of highlighting the contrast between the different colors in the image. And in my next video, I'll actually be talking about those methods and showing some examples.